Hello student. Now I'll give you some idea on laws of exponents for real numbers. Now you see I'll give you some point. So you write it down at home. You just try to remember these laws. Now what does it mean you see generally? Say suppose your first law, just I'm writing here first law a to the power say a to the power m into a to the power n, a to the power n. You see here, what does it mean actually? Clear? Now suppose here a actually, when we write a to the power m, this one in the middle which you have written here, this is known as base. Clear? And this term which you write it as a superscript, that one we write it as a exponent. We call it as exponent. Clear? Exponent, or sometimes we call it power. Clear? Power, remember that. So as a superscript, the one which you write, that one is known as what? Your exponent. And here, the one which you write in the down, that one is your base. So here, when you see this type of condition, a to the power m into a to the power n, so here a and this a can be any real numbers, m and n are all also any integers. Clear? So on real number, just you see laws of exponents for real numbers. That means this a and m are any natural numbers, we can say. So a is called this a is called base. Clear? This a is called base. Remember, and m and n are called what? Exponents. Just remember that. So when you see the base is same, there is a, the powers are different. So in case of multiplication, there is a law. We write a to the power m plus n. So you have to remember this. Clear? Because by using this this formula, we have to do some problem. Clear? Related on real numbers. When you do some calculations, we have to apply this law. Clear? So always remember, in case of multiplication, if the bases are same and the powers or exponents are different, then we use this law, a to the power m plus n. Clear? The same way, if we write suppose number 2, a to the power m whole to the power n. So this means this power a to the power m whole to the power n, then we multiply these powers a to the power mn, we write mn. This power m and n will multiply together mn, we write it like this. Clear? And another law we write, you see, we write when we divide a to the power m divided by a to the power n, and in this case suppose m is greater, just remember, in this case suppose m is greater than n. Clear? So in that case we can write, there is here a to the power m divided by a to the power n. In case of division, if the base is same, powers are different, we subtract the power a to the power m minus n. Remember this law. Clear? Because we'll use this law in order to do some numerical problems in the exercise. Clear? Exercise 2.1. We'll see when I'll do the problems, will we apply these laws of exponents. Clear? So this one. And another one, say number 4, a to the power m, just say a to the power m into b to the power m. You see here the powers are same, m, the bases are different, a and b. So in that case we can write a b whole to the power m. Clear? So that way we can say. And another one, we can say any value, suppose a to the power 0, a to the power 0 is equal to, we write 1. Always this value we'll use. Clear? So these are the simple things you have to remember. And another one, suppose a to the power, suppose minus n. If we just write a to the power minus n, then to make the power positive, we write 1 by a to the power n. Clear? Or 1 by a to the power n is equal to, just in reverse form we write a to the power minus n. These laws what I have written here, you remember. And you know why a to the power 0 is equal to 1, I have shown in the class already. You know how to do, how we got this one. Clear? So just you have to remember these laws. So using this law, we'll do the exercise problems exercise problem, I mean 2.1. You see one problem I'll show here, not much, only one problem I'll show. So here in exercise problem, you see here exercise 2.1, oh sorry, 1.5 here, not 2.5, 1.5 exercise 1.5. So in exercise 1.5, find 64 to the power 1 by 4. You have to find out the value of this. Clear? Now how to do this? You see 64 to the power 1 by 2. You have to 64 to the power 1 by 2. How to find out this value? See, this 64 we have to split it up. Now 64, if you just split, just I'm showing it here, 64 if you split, so here the last digit an even number, you see the last digit and even number, that is 4, so we can divide it by 2. So always we try divide it by a prime number. Clear? So first of all, if the last digit is 0 or an even number, then always that number is divisible by 2. That divisibility test, you know, we'll divide it by 2. Now 2 3 is 6, 2 2 is 4. That means when you divide any number by 2, you get half of that number. That is 64. If you divide by 2, you get 32. Clear? Now again this 2 is an even number. Again we will divide by 2. Now 2 1 is 2. 3 minus 2 1. 1 and 2 12. 2 6 is 12. Clear? So half of 32, you know, 16. So directly whenever we divide by 2, just think we make it half. Clear? Now again 2 we will write, because an even number. 16 divided by 2, we get 8. 8 to the 16. Again an even number, we will divide it by 2. So you know 2 4 is 8. Clear? Then again this is 4 an even number, we will divide it by 2. So 2 2 is 4. So when we get the last number, an even number, no need to do it once again. So we write it as it is. 1 2 3 4 5 6. So here 64 means 2 to the power 6. Clear? We can write as a 64 is equivalent to 2 to the power 6. So this number 64, we'll write it as 2 to the power 6. Got it? Now whole to the power 1 by 2 is there. Now you see, for the laws of indices, 2 to the power 6 into 2 to 1 to whole to the power 1 by 2. This is your n, this is your n. So on this law will apply here. Which one? This one, number 2. A to the power m into a to the power n is equal to a to the power mn. Clear? So here, that means in this problem you see 2 to the power 6 into 1 by 2. Clear? Now you see here this one we can divide. 6 1 is 6 and here 2. So 6, this 6 we can divide by 2. 2 1 is 2, 2 3 is 6. That means this one also you have divided by 2, this one also you have to divide by 2. Clear? So denominator is 1, so we need not to write this one. So we are getting 3 1 is 3. Clear? So we will get 2 to the power 3. Now 2 to the power 3 means what actually? 2 3 times. 2 into 2 into 2. That you know. 2 you have to write 3 times. Now you multiply 2 to the 4, 2 to the 4, 4 to the 8. So that would be your answer. Clear? So just I have shown you just little bit long way, but you can make it short also. When you see the denominator of of any number, the exponent of any number is a fraction with some denominators. So if possible, you try to split it up in such a way so that the exponent of that base you get in the power of the denominators form. So short way, or if you do like this, suppose you know, if you're a little bit expert, you know 64 is 8 square. That means you can write this 8 square. Clear? That is into 1 by 2. You see 1 by 2. 8 to 8 square into 1 by 2. Then this 2 will get cancelled. 8 to the power 1 will get 8. So directly we are getting, but just for your understanding, just I am showing you this one. So if someone choose the correct answer, you have to choose 64 to the power 1 by 2 would be what? Then directly you can find it out. Just for calculation purpose, I have shown you this rule and all. Clear? Just to find out these answers. Clear? Let's say anyway. So 64 to the power 1 by 2, we got 6. Clear? So this way you will try question number 1, sub number 2 also. 32 to the power 1 by, you see, 5. So here you see the power of this the power of this denominator. Clear? The power of this denominator, you see what is written? 5. Clear? 5. So here if you split it up, 32, then you will get 2 to the power 5. Then 5 will get cancelled. So 2 to the power 1 is 1, 2. So that way you will get the answer 2. Directly you can do. Clear? So same way you will try number 3 also. 125 to the power 1 by, what is this written? 3. Clear? So it is written, you see, 125 to the power 1 by 3. Clear? Now you split it up in such a way so that the power of that base will get 3. Clear? So you'll get 5 to the power 3 into 1 by 3. 3 will get cancelled, 5 to the power 1. So the answer will be 5. So verbally also you can do this one, but in order to do it in the copy, you have to just show the calculation part. Clear? So that way you try. And in the next video, I'll show you this question number 2, sub number 1, 2, 3 and all. Even you can try this also, but if not possible, I'll show it in the next video. This question number 2 later on. Clear? So just remember the laws of exponents nicely here. Only I have written 6 laws here. Number 1, 2, 3, 4, 5, 6. And using that law, you have to do all the problems of this exercise 1.5. So if you are well versed in this formula, then easily by yourself you can do these problems. Clear? You can solve it out. Clear? So I'm leaving up to this much. You see the video nicely and try to do question number 1.